Hi, welcome back to the stream. My name is Prakash, or PH, and today we are going to be going over Structe's pair sum solution problem. Yeah, let's just jump right into it. I have it already written out, and let's just go from here. All right. Let's see if the stream is actually showing up. Cool. All right, write a function pair sum that takes in a list and a target sum as arguments. The function should return a tuple containing a pair of indices whose elements sum to the given target. The indices returned must be unique. Excuse me. Be sure to return the indices, not the elements themselves. There is guaranteed to be one pair that sums to the target. So 0 and 2 equals 8. Okay. Hmm. Uh, hmm. You need to know what a tuple is. That is a tuple in Python. All right. In Python, a tuple is an ordered, immutable collection of elements. Here's what that means. Ordered. The elements in a tuple maintain their order just like in a list. Once you create a tuple, you cannot modify its contents. This means you can't add, remove, or change elements within a tuple. Use parentheses to enclose the elements separated by commas. So 1, 2, 3, hello. You can also create a tuple without parentheses, only using commas. To create a tuple with a single element, add a comma after the element. Use indexing to access individual elements, just like in a list. Bruh. Okay. All right, we won't worry about that right now. So first, I'm assuming we would. Yeah, we should start with a dictionary. And we should have a dictionary because we want to push. Well, I wouldn't say push, but we would like to put in these indices into that to find out if the sum will equal. Right. So yeah. So like find okay. All right. So we're going to loop let's print out I. Let's just do that. Oh. Oh yeah, let's not do these big ass ones. So Let's just do 1 right now. Jeez, just commented these out. Yeah. All right, so 3, 2, 5, 4, 1. Okay. If we check the numbers, so then we check in here for the the index. So we need another loop. Let's do an F string of I. And, we gotta close that. All right. It's not. See if the stream is going through. Okay. 1 second. Okay. Um, so- I feel like yeah. Okay. So 3, 3, 3, 3, 2, 3, 5. It feels like I've done this before. 3, 3, 3, 2. We don't want to do this. We don't want to add. So it'd be like 3, 2, 3, 5, 3, 4, 3, 1. Okay. So if I is not equal to j and I and if I plus j is equal to target sum, then let's just say print I and j. Oh. So 3, so so 3 and 3, 6, 3 and 2, 3 and 5. 5, 3 and 4. Oh, so 3 and 4, 3 and okay, and then we go to 2, 2 and 3, 2 and 2, 2 and 5. So the number is 5. So 2 and wait, 2 and 3. That should have equaled 5. Oh no, sorry. We're like, wait, what am I doing? Oh, I'm stupid. I was like, this doesn't make sense. Let's try again. I was like, what? Well, it's not even doing it. Oh, wait. Oh, I didn't save. That's why. I was like, huh? Let's do 4. So, no. So 4 and 7. So 4 and 4. No. 4 and 7. No. 4 and 9. No. 4 and 2. No. 4 and 5. No. 4 and 1. And then let's print out I plus j. Yeah, so this equals 8. Five plus 3 is 8, right? 4. Okay, so then now that we just need to find the index, so return the return nums I and see. Let's try this. Okay, did it even go through for? We're not even using the. So I thought we could just iterate. Okay, we don't really need that. Oh. Hmm. I'm gonna need their approach video.
Hey programmers, Alvin here. Right now, let's go over the approach we can use for this pair sum problem. So in this problem, what we want to do is take an array of numbers as input. We're also going to take in a target sum. What we want to do is return a pair of indices whose elements sum to the target.
Oh
In other words, the 3 and 5 elements over here definitely have a sum of 8, which is my target. What I want to do is really return their indices, right? So I can find elements 3 and 5 at indices 0 and 2. There are a few constraints for this problem. They tell us that we can't take the same element twice. In other words, we have to return unique indices. We're also guaranteed to find one pair that meets this criteria. And so what would be a way to solve this one? Well, let's go over two solutions. We'll start with the brute force solution, which would mean using nested loops. A very common programming method is to look for pairs, and in general, the most straightforward way to implement that would be to use two loops, right? One loop to iterate every first element, and then another loop to iterate for every second element. And that would give you your full pair. So the way we can kind of visualize this is just listing out our array twice over, although in the context of our code, we're only going to have a single array, right? I'm just using this notation to represent some nested loops. So above I'll have like my I loop, and here I have labeled all the indices, and below I'll have like my J loop, right? Also labeling its indices. Let's say we're on the first iteration of this loop. I would be comparing element 3 with element 3. That's actually not so great because in the problem they tell us that we need to look at unique indices.
Right, you can't.
Now I'm comparing index 0 to itself. So instead what I'll want to do is actually begin my inner loop at 1, really just adding 1 to the current value of I, right? And this would now be a legal pair to consider. Obviously, when it comes to the context of my main problem here, if I just do 3 plus 2, adding the elements, I get a sum of 5. Since that sum is not the target, I didn't find a valid pair. The next iteration, I would be comparing 3 to the 5. So I do 3 plus 5, which would give me 8, and that would actually match my target. Right? So this would be the valid pair to return. But let's say we didn't find it. We would, of course, keep iterating in this way. So while I keep my I fixed, I would increase my J, until eventually I need to increase my I and start my J's all over again. Of course, in this particular input, we'd be returning for the 3 and 5, though. We want to return the indices, so return index 0 and index 2. Nice. And when it comes to all the different iterations we'll do for this brute force algorithm, we would do quite a bit. Right? We're going to consider every possible pair of numbers within our array. And so what would the time complexity of that be? Well, for this nested loop algorithm, let's say n is the length of the array. Whenever you nest loops like that, you would be multiplying their complexity, so n times n, which of course is n squared. The space complexity here is actually constant O of 1. So for this problem, we'll want to do better. There is a solution out there that has a better time complexity. In other words, how can we solve this in linear time and linear?
Fudge. Can we just solve it go with this first? So we can worry about the how to do it tomorrow. Yeah, so then just... Oh, then we could just go back. Can we append? Can you append to a dictionary? Hey, Yumi. Not Python. No, it needs to be a tuple. Okay. Can you append? How do you declare and initialize a tuple in Python? So let's just put tuple. Oh, indices tuple, which would just be. So then, how do you append to a tuple in Python? You cannot directly append. Oh, geez. Because tuples are immutable. Right, we talked about that. I read that. They can't be changed once created. However, you can achieve a similar result by creating a new tuple that combines the elements of. What if there's nothing inside? Let's erase this. Let's erase that. Let's erase this. Okay, I'm. This is definitely not going to work. Yeah, no. Oh no, because it's numbers I and numbers J. Again, still don't think this is gonna solve anything. No. List out of range. What does that mean? Huh? Oh, because it's immutable, so you can't do that. What if we declare it here? Hi. Well, first, let's even see if anything comes up. I keep saving. No. It keeps saying that it's out of range. Is it because we're in? How? Okay, let's just try this. What about numbers J? Bruh. What? How? What data structure can I append an a an arrays indices into in Python? But it said it didn't want that, so it's okay, bro. Why does it keep saying that it's out of range? Wait, no. For I in range of length of numbers. How would that change? For I in range, loops iterates the indices of the list, allowing you to use to access the. Oh, I'm. Oh my gosh. I get it now. You can't do that with. Bruh. Let me just copy and paste this because it's my solution. So might as well just. Why is it so far back? Ugh. Alright. Ooh. Okay, let's try. Because my brain is. I was expecting a double. I forgot. Oh my gosh. What? I don't want to. I really like this, but bruh, I don't want to. How can I? My solution is correct. However, it is expecting a tuple instead of an array. Can you help me fix this? Because I don't know how to do tuples just yet. So just do that? Bruh, that's not, it can't be that easy. It can't be that easy. Come on. Don't. Okay, it passed, but no, now we have to do. Why isn't. Oh. Because. Wait. When this and this make that? So 0, 1, 2, 3. Yeah, what the fuck? I was like, shouldn't that just solve that? Okay, now I don't know, bro. Wait, what does that even say? Okay, so for I in range of 1 to bro, I'm sorry. I'm not about to do this. How can I solve this edge case problem? I don't have. I'm so tired. What? Left, right. Find the indices of two numbers in the given list that sum to the target. Arguments, numbers, returns a tuple containing the indices of the two numbers if found, otherwise an empty tuple. While left is let's do this. Let's do this shit. Let's see if this works. Because this is not my solution. But no. I just can't think right now. Okay. See, this is what I'm talking about. No. I want this return. Yeah, it passes all of these, and it just doesn't pass this one. So, shit. Oh my gosh, I'm itchy. How can I solve this edge case problem? And here's my code. Even though this is not the best solution, it's my brute force way of doing it. The code you provided has a potential issue with performance when handling large lists like one of the generated from four numbers. It's using a nested loop, which I know it's O of n. For a list of size 600, this approach can be slow, especially if there aren't larger inputs. Additionally, there might be an inefficiency in the way indices are checked, which could lead to unnecessary computations. To fix this, improve performance, you can use a hash map dictionary. Is there a way? There a way with my code to solve? For I in range of, for j in range of I plus 1, start j from I plus 1 to avoid duplicates and redundant checks. If numbers... Okay, I could do that. I could do that. I just want to keep my solution kind of... So yeah, it starts at I plus 1, and then... Let's just take out the return. Okay, so again, we understand that time complexity, because it is inefficient, so it is big O of n squared. But I think that the space complexity is... Oh my gosh, I can't. Complexity is O of big O of 1. That's my final answer. So let's see if it's right. And it is not. Well, it wait. Would the with my solution with my brute fort is the tying complexity big O of n squared and space complexity of O of 1. Yes. Okay. I'm tired. Okay. Right. The nested loop iterates over pairs of indices. Outer loop runs because this is already O of n, but then with this it becomes O of n squared, and then right. So 2 n's equals this. So again, not the most efficient way of solving this problem. And then the complexity, the space complexity, yes, we're only yeah. The extra space used in the loop counters or temporary variables, which are constant and independent of the size of it. Right. Let's erase this. All right, guys. I am. What is causing? Is it because this music is super loud? Let's fix that. Hope my stream is not like blasting. I can't hear the music. Okay. Anyway, guys, I am quite sleepy. We're gonna have to end it here for tonight. Thank you all for watching, and I'll see you guys tomorrow, preferably a little bit earlier than this. So, thank you guys. I will see y'all.